What if everything you've ever been taught about the Big Bang was wrong? A radical new theory is shaking the foundations of modern cosmology. It challenges the very idea that the universe had a beginning at all. In this video, we dive deep into a bold new proposition that the universe didn't begin with a bang, but instead, it creates itself. No singularity, no edge of time, no moment of let there be light. Could this mean the universe has no beginning and no end? Let's uncover what scientists are now proposing and why it could change everything we know about reality. The Big Bang theory has dominated cosmology for nearly a century. According to this model, about 13.8 billion years ago, the universe burst into existence from an infinitely dense point called a singularity. This moment marks the beginning of time, space, and matter itself. The theory is supported by several key observations: the cosmic microwave background radiation, the expansion of galaxies, and the abundance of light elements. Yet, despite its success, the theory has always left scientists uneasy. Why? Because it doesn't explain what came before the bang. In fact, it can't. The laws of physics break down at the singularity. This forces us to accept the uncomfortable notion that our universe simply popped into existence from nothing. That's not just counterintuitive, it's unsatisfying. This frustration has led researchers to question whether there might be a more elegant explanation, one that doesn't rely on an arbitrary beginning. Recently, physicists have proposed a groundbreaking alternative: the idea of a self-creating universe. This model suggests that the universe may have no beginning at all. Instead, it's a closed, self-contained system, something that creates itself through quantum processes. One version of this theory, based on loop quantum gravity, avoids the singularity by proposing that time is not linear. Rather than a big bang, there's a big bounce. A previous universe collapsed and rebounded into the one we now inhabit. Even more radical is the emergent universe model. Here, the universe eternally exists in a stable state until quantum fluctuations trigger an expansion. There's no bang, just a graceful transition from timelessness to time. This reframing allows for a cosmos that's always been there, evolving, recycling, and self-generating without ever needing to be created from nothing. If the universe didn't begin, then what is time? According to the self-creating models, time might not be a fundamental feature of the cosmos. Instead, it could be emergent, arising only under specific conditions like temperature or energy density. Think of time as a property that only switches on when the universe reaches a certain state. Prior to that, no ticking clocks, no before or after, just a timeless quantum sea. This is where quantum gravity enters the picture. Combining quantum mechanics with general relativity, some physicists believe space and time both emerge from a deeper, more abstract reality, a pre-geometric state. In that framework, the universe is more like a hologram of interacting information than a physical place with a ticking cosmic clock. This idea is mind-bending, but it's gaining ground, especially since the Big Bang can't explain what initiated time in the first place. The self-creating universe theory has both supporters and skeptics. Some physicists are drawn to it because it elegantly avoids the need for a singularity. Models like loop quantum cosmology, causal dynamical triangulations, and emergent spacetime are being developed to support this view. Mathematically, these models are still in early stages, but they're already providing insights. They might explain anomalies in the cosmic microwave background or even hint at a pre-Big Bang phase. Critics argue, however, that these ideas are too speculative and currently lack definitive observational evidence. The Big Bang still fits much of the data we see today. Until new measurements arrive, perhaps from the James Webb Space Telescope or future gravitational wave detectors, the debate will rage on. But make no mistake, the cracks in the Big Bang are growing, and scientists are being forced to explore new horizons. If the universe is truly self-creating, it flips our entire worldview. No beginning means no creation event. No creation event means no need for something to cause the universe. Philosophically, this sidesteps the age-old first cause argument, often used in theological contexts. Instead, the cosmos becomes an eternal, self-sustaining system. It means reality may be fundamentally circular or cyclical, without a true origin point. This reshapes our understanding of life, time, purpose, even our place in the universe. And perhaps most fascinating of all, it invites us to consider that existence itself doesn't need a cause. It just is. This theory might never fully replace the Big Bang, but it could coexist with it, or reveal a deeper, more unified picture of reality, one where creation is not an event, but an eternal process. At the heart of the self-creating universe theory lies the mysterious world of quantum fluctuations. These are tiny, random changes in energy that occur even in a perfect vacuum, a result of the uncertainty principle in quantum physics. In classical cosmology, nothing can come from nothing. But in quantum theory, even nothing is teeming with potential. A quantum fluctuation could spark a phase transition, causing a universe to expand, evolve, and become what we now observe. This idea forms the backbone of the emergent universe model. The universe could have been sitting in a timeless, unchanging state forever. Then, a single fluctuation changed everything. Time emerged, expansion began, matter formed. Crucially, this doesn't require a creator or an external cause. The universe emerges from the laws of physics themselves, from the raw potential embedded in the fabric of reality. One of the most mind-blowing implications of the self-creating model is the possibility of a pre-Big Bang universe. If the Big Bang wasn't the beginning, then what came before? Some theories suggest a contracting universe, a mirror image of our own, collapsed before rebounding into our current expansion. Others hint at an infinite chain of universes, each birthing the next in a cosmic cycle. In loop quantum cosmology, the equations don't break at the singularity. Instead, they allow time to pass through it, showing a universe that shrinks to a minimum size before bouncing back. That bounce may have wiped all memory of what came before, but traces could still exist. Subtle imprints in the cosmic microwave background or patterns in gravitational waves might one day confirm this cosmic lineage. Some versions of the self-creating theory intersect with the idea of a holographic universe. In this view, everything we perceive as 3D space, stars, galaxies, and ourselves, is actually a projection of information encoded on a distant, lower-dimensional boundary. This isn't science fiction. It's based on real physics emerging from string theory and black hole thermodynamics. If space and time are just emergent properties, the universe might function like a giant quantum computer, calculating its own reality through information exchanges. In such a model, the universe doesn't require a bang or a beginning. It unfolds like the rendering of a video game world from encoded data, and that encoding may be eternal. Albert Einstein was never fully comfortable with the Big Bang theory. He believed the universe should be orderly, rational, and, if possible, eternal. Though his general relativity equations predicted a dynamic universe, he initially resisted the idea of cosmic expansion. But today, some physicists believe Einstein may have been closer to the truth than he realized. Self-creating models align with his vision of a deterministic cosmos, one governed by laws, not randomness. They offer a return to elegance, a universe that doesn't need miracles or singularities to explain its birth. In that sense, modern physics is circling back to complete Einstein's work by developing models where the cosmos always existed in some form, evolving smoothly and logically. What if time, as we experience it, isn't fundamental? In the self-creating universe model, time might not exist at all in the deepest layers of reality. Physicists like Julian Barber and Carlo Rovelli argue that time is an emergent illusion, arising only when matter interacts in certain ways. At the quantum scale, the universe may be timeless, existing as a static web of relationships. Our perception of past, present, and future could be a byproduct of entropy, the tendency for systems to move from order to disorder. In a low entropy state, time feels slow. In a high entropy universe like ours, it races forward. But if time isn't real in the way we think, then there's no need for a first moment or beginning. The universe could be timeless and eternal. The self-creating universe concept often overlaps with multiverse theories. If quantum fluctuations can spawn one universe, why not many? Inflation theory, the idea that space expanded faster than light fractions of a second after the Big Bang, naturally predicts the creation of countless bubble universes. Each bubble has its own laws of physics, its own constants, even its own time and space. In this view, our universe is just one of many, an island in a vast sea of cosmic possibilities. The multiverse adds weight to the self-creating model by showing that creation isn't a singular event, but a continuous process. And if the multiverse has always existed, then creation never needed a beginning. A universe with no beginning has profound implications beyond science, especially for religion and philosophy. Many faiths are built on the idea of a moment of creation, a divine act that brought everything into existence. A self-creating, eternal universe challenges that narrative. It doesn't disprove spirituality, but it reframes it. Philosophically, this model resonates with ancient traditions like Hinduism and Buddhism, which describe the cosmos as cyclical and eternal. It also echoes ideas in Stoicism and certain interpretations of Spinoza's philosophy. In short, science is converging on ideas that mystics and philosophers have pondered for centuries, that existence is not a question of when or why, but simply is. One of the most puzzling aspects of this theory is redefining nothing. In physics, nothing isn't truly empty. It's a quantum vacuum, a sea of potential, where particles and antiparticles constantly appear and disappear. This vacuum is governed by rules, equations that determine how energy behaves. So when we say the universe created itself from nothing, it's not from absolute nothingness. It's from a foundational quantum field, a structured, law-driven form of nothing. This changes the meaning of creation. It's not magic. It's not a miracle. It's a shift in the state of a quantum system, a natural consequence of the universe's own rules. Testing the self-creating universe theory is difficult, but not impossible. Scientists are looking for specific signatures in the cosmic microwave background that might show evidence of a pre-Big Bang universe. Gravitational wave detectors may also one day pick up ripples from before the so-called beginning. Other tests could involve high-energy particle physics or simulations of quantum gravity. Theoretical models like loop quantum gravity and string theory are still being refined to make concrete predictions. While it's early days, science is inching closer to turning this philosophical idea into a testable hypothesis. Entropy, the measure of disorder, plays a key role in the idea of a self-creating universe. In thermodynamics, systems naturally evolve from order to chaos. The Big Bang is seen as the lowest entropy moment in history, and everything since has been increasing entropy. But in a self-creating model, entropy might cycle. A universe that contracts, bounces, and expands again could reset its entropy each time. Alternatively, entropy could exist in a balance, creating stable conditions for life and matter to exist indefinitely. This would mean cosmic history isn't a one-way street to heat death, but an eternal dance of balance and renewal.